we go. Acids were compounds that release hydrogen ions when they're dissolved in water. We had a bunch of names for different kinds of acids. These acids all have different uses. The defining factor for the chemical formula for an acid was this extra hydrogen. Usually that hydrogen is found out front. The only exception would be this guy here in vinegar, also called acetic or ethanoic acid. That H is often found out back. But all of the other acids, hydrogen is going to get listed out front. The contrasting compound for acids were bases. Bases were compounds that release hydroxide ions. So the OH that shows up outside, or the back half of your chemical formula, that's the hydroxide that shows up. The general formula will have a metal of some kind out front and then the OH out back. We had some properties for bases. I gave you a list of formulas for bases, some of their common names and their uses. Then I introduced to you guys the pH scale. The pH scale was the scale that we used to look at how acidic or how basic something is. The scale goes from 0 to 14, and different kinds of materials show up at different places on the pH scale. So things that are acidic are down here on the 0 to 7 side of the scale. Things that are basic are on the 7 to 14 side of the scale. And if you're right in the middle, you're not acidic, you're not basic, you're neutral, that goes right in the middle, pH of 7. And if we, down here, to be neutral on the pH scale, means you have to have the same number of H plus ions as you do OH minus ions. And so we looked at that and said, well, if I have equal H's and OH's, I just have water, which is why water is in the middle. It's why water is considered neutral. So we had a bunch of different things that showed up here. We had stomach acid, is quite a strong acid. It's also called hydrochloric acid. Then we had oven cleaner over here on the far right-hand side. It's a strong base, NaOH. And I said that the scale was logarithmic, so if you recall, I mean, it was 3 weeks ago now, but what that means is every jump on the pH scale of 1, so to go from 7 to 6 or to 6 to 5, from 5 to 4, every one of those jumps means you're getting 10 times stronger of whatever side you're on. So if you're going from 7 to 6, that's a jump of 1 pH level, but because you're on the acidic side, so milk here, for example, would be 10 times more acidic than water is. A banana is 10 times more acidic than milk is. A tomato is 10 times more acidic than a banana is. So as you move down the scale, you're jumping multiples of 10. The same is true the other way. Eggs are more basic than, or 10 times more basic than water. Baking soda is 10 times more basic than eggs. Soap, 10 times more than baking soda. And then you get into some of these nasty ones over here. These guys are all, the line kind of exists between soap and ammonia. Where up to soap, we use these as decent cleaners. If you were unfortunate enough to ever have your mouth washed out with soap, if your parents still did that, I grew up in an era where that was a thing. You said a bad word, you got your mouth washed out with soap. Generally speaking, you good? Okay, do what you got to do. If you need more paper towel, I have a whole roll over here. Does nosebleed? There's a roll there too? Okay, cool. I grew up in an era where the mouth washing out with soap was a thing, but you move any further onto the basic scale, now all of a sudden, this isn't going to wash out your mouth, it's going to kill you. Ammonia, bleach, and oven cleaner are all fairly negative things to experience. And so we have the pH scale. We use what are called pH indicators. I gave you some homework to take a look at, which we will go over in a second. We looked at pH indicators. So not only does the scale exist, we need to figure out how we can measure where things are on the scale. And this was the first lab I had you guys do, the properties of acids and bases. I gave you 1, 2, 3, 4 of these indicators, and I had you guys measure 4 different materials, unknowns A, B, C, and D, and your job was to figure out where or what order they were. Yeah, list the unknown solutions in order from most acidic to least acidic. Which solutions do you think were neutral? Explain how you know. And so we used the property of acids and bases, that acids react with metals. So that gave you magnesium strips. Bases and water do not. And then these indicators here, methyl orange, bromethymol blue, litmus, and phenolphthalein. Or no, was it indigo carmine? What did I give you? It was methyl orange. It was not this one. It was this one, indigo carmine. And you guys used these indicators and the colors that they changed to determine whether something was acidic, basic, or neutral, and you put them in the right order. That was the goal of that lab. So for example, if methyl orange was turned red in something, that means the pH is down here 0, 1, 2, all the way up to 3. Between 3 and like 4.5, methyl orange is going to be like the blend of these two colors, the red and orange, so it's going to be orange. And then beyond that, methyl orange was supposed to turn yellow. Likewise, bromethymol blue down here on the acid side would be yellow. Up here on the basic side would be blue, and it would be the blend of blue and yellow, so green, for neutral solutions, and it was green for one of these things, and so on. The second lab, the which solution is more acidic, I think most of you got a chance to start it, but you were playing with, in that one you were playing with phenolphthalein. You added phenolphthalein to a colorless solution, and you were trying to see how which solution is more acidic. So you added phenolphthalein to an acid, and then you started to add a basic solution to the acidic solution, and once you'd added enough base to get rid of the acid and to make it basic, it started to turn pink. If you haven't seen that, then you will have a chance to do that. So that was the point of the second lab. Which solution is more acidic? Gave you 3 acidic solutions and we played with them from there. Questions, comments, concerns up to this point? Okay. There were a chunk of questions, these guys here, the pH scale, that I wanted you guys to take a look at, this page and the next page. That first thing we'll do in class tomorrow is I'll provide you answers to that. I also wanted you to take a look at this, the pH indicators. Before you did the lab, I wanted you to do these questions. And this one we had left. We weren't going to do this one yet. Not yet. That's an M. That's as far as we'd gotten. We looked at these pH indicators, and then we jumped into the labs. Are we all more or less on that same page? Okay, cool. And some of you guys are done those already. Yeah. Oh, now do I start this thing? Okay, so here's, this is very difficult because you guys are on the same different spot than last block. Okay, I am going to, yes. Those of you who are done both labs, how many of you are done all of what I assigned as far as the questions go? Are any of you done everything I've assigned? Fantastic. Okay, here's what, the rest of it, so an hour now. Yes, about an hour. I've killed the first 20 minutes. We've got an hour now. What I want you to, those of you who are not done the lab, you guys are gonna have time today to finish this up. Or if you screwed it up, you wanna restart, we're gonna finish that. So which solution is more acidic and the properties of acids and bases. I want you to get those labs out. If you have finished them and handed them in, great. If you haven't handed them in yet, get them out. You've got questions to answer on one or both of these things. There's also a set of questions that I assigned. I wanted you guys to look at the pH scale. I wanted you to look at pH indicators. And now, in addition to that, this page here on acids versus bases, you guys can now finish as well. And I'm going to pull out, we'll pull out the rest of the labs. So here we go. Let's do this. If you have nothing to do, any of you have absolutely nothing to do, call me over and I'll take a look at where things are at. But I've got the lab handouts over here, which solution is more acidic, properties of acids and bases. If you guys need, those of you who are still working on properties of acids and bases, that's this box right here. It will sit on this table right here next to the remote control trucks, and you will be able to get anything you need for that lab right there. If you're working on which solution is more acidic, that's this wheelie chair right here. Let's move this, or wheelie cart right here. It's going to live up here at the front. You can get what you need over here. Make sure you guys actually grab what you need. Don't screw this thing up again. On your mark, you set, go. Get you to where you need. Call me over if you are unsure how to proceed. Okay, there were 2 labs. Yeah? Okay. What do you mean? You're the only one. You guys finish? Okay. Start with this one. Properties of acids and bases. Have you finished? So it was moved on. So start with that one. You got some reading to do. All the materials you need for that one. Remember, you guys need goggles. If you're doing a lab, you gotta wear goggles. How are you? Okay, goggles up if you're working on labs. Okay, let's see what we've got here. Okay, so Kiwaena, Angel, and Namaste. Malik. Oh yeah, so many of you guys have things to do. Okay, Liam, I don't have the properties of acids and bases handed in from you. I've got the other 2 guys. Do you have that handout? Okay, then that's what you and Josiah can be working on together. You guys can do this lab together. If you don't have this handout, it means you weren't here for the lab. I also have Luca and Dennis's, which solution is more acidic. Yeah, you've done both. You're the only one that's done both. For the 2 of you need to work together on these 2 labs. No, I don't have a handout. You have to grab the handouts. Okay. Yes. So many of you have not finished. This is good. Okay. Spot this. Not and then you put it in the wrong bin. What's that? Yeah. Where'd my 0.7 go? I gave some to Ray Reeds. Where did I put it? Oh, shoot. Oh, there it is. Yeah. Yes, I'll open up the bathroom. Okay. There we go. Okay. Yeah, see those that you didn't hand in? Those are not. Okay. So where are we at here, you guys? Yours is. Nope, you're done. You have to switch your one of these. Right, so. How are you guys? On your face, not your chin. Remember, Lexi's allowed to poke you in the eye. Okay, you two. Where are your laps? Yep, get those up. See where you're at. Finish that one. Okay. And you were about to start the second one. But you had cool. Go get your hand out because you had done this. Behind you. Done. Yeah. And you started to dig the hole. So he has the result of his sheet. Cool. So you've done that usually with his data. Cool. Yeah. Then do the questions you did. Don't do it again. Yeah. Yeah. Sounds good. Sounds good. So you've actually done. You sent out some questions. You asked. Love it. Okay. So you guys need to get close over there. The A, B, C, and then the. Yeah, no, this is all this over here. Yeah, we have more decibel collected. Take two. Okay, so gentlemen, what are you working on here? Cool.
Issues with the air. Issue with the intercom system. I'm confused.
The bromethymol blue? And you've looked in, obviously you've pulled them all out? What happens? And then this is just for your reference. Red here, I would label this 7. You'll need this table to reference what you see happening on the chart. Hold on. Why did you just do that?
So now we have to do it again.
Okay.